So we left off about here. We got a few slides into the conversation about abstract methods and abstract classes and eventually interfaces. So I'll back up a little bit so we can refresh ourselves on where we were at, what we were doing, and talk about abstract methods and stuff. So abstract methods are methods that specify the name of the method, the parameter list including types, and the return type of the method, but don't have any implementation. We just close it off with a semicolon and call it done. This is an abstract method, a method with no definition, doesn't even not do anything. It is undefined what this method should do. So if you have any abstract methods in a class, the class itself has to be abstract. What this means is that you can't, the most important thing that this means is you can't create an instance of this class, of this type. You cannot say, since game item is an abstract class now, we cannot say new game item. Can't do it. Even though it has a constructor, we can't call that constructor directly. That constructor is only ever going to be called through inheritance by a subclass constructor. So with an abstract class, we can't create objects. We can't say new game item. And the reason for that is, say we allowed that. Say Java's like, you know what, you can create objects of types of abstract classes. And we say new game item, and then with that object, we say .use. What should happen? The method's not defined. It doesn't even have a body. It doesn't even do nothing. It's completely undefined. We have a signature with no definition. So what should it do? I don't know. Java doesn't know. And Java's just going to not let you do that. So once you say new game item, Java's going to say, you can't do that. It's an abstract class. Try something else. Because the class is only partially defined, it has some abstract methods, we're not going to be allowed to instantiate it. Not directly, anyway. We're going to instantiate it, in a sense, by extending it with weapon and potion, and then creating new weapons, new potions, and then those will call this constructor and inherit all the Satan behavior. That's the only way we're going to use this code, is by using inheritance. So if you extend a class with any abstract methods, if you extend an abstract class, you have a contract to fulfill. You're saying, hey, I know I'm extending something with an abstract method. I will guarantee that I will implement that method. That's what extending an abstract class means. You are promising that any abstract methods in that class, you will give a definition. You will override it. You will implement these methods and give them definitions. So the abstract class says anything that extends me will have this method. I don't know what it's going to do, but they will have this method. And then it's up to the inheriting classes to guarantee that they will implement that method. They will override it. There's only one exception to this. If you extend game item and don't implement the use method, that class itself has to be abstract because it's still not fully defined. It has an obligation to implement the use method. If it doesn't implement it, it has to be abstract. It can't be instantiated. Only once you have something that in the inheritance chain that implements all the abstract methods, then and only then can it be a class and not an abstract class. Cool, but why? So why would we ever use an abstract class? And this is a conversation we've avoided, by the way. In inheritance, we could have been using abstract classes, abstract methods, and eventually interfaces that we'll see on the next slide. And if you've done OOP in Java before, you were probably wondering why wouldn't we? Like, why aren't we having that conversation? And my answer to that is, well, one, inheritance week had enough stuff in it already. That was already pretty mentally taxing when we were first learning inheritance. And it's not too long after you first learn classes. It's just a lot. In polymorphism week, we didn't have too much to talk about, so we just balanced the concepts throughout the course. That's one answer. But also, there's really no reason to use abstract methods until you start using polymorphism, in my opinion at least. There's some benefits, but you don't really get the benefits until you're using polymorphism. So with polymorphism, if you have an object stored in a variable of a different type, so when we have a potion stored in a variable of type game item, I said you can only call the methods that are known to the game item class. But I never said you can only call the methods that the game item class defines, just methods that are known to the game item class. So if we have an abstract method in the game item class, game item knows about that method. And now when we're using polymorphism, we can call that method. If we have a game item class and we say, okay, anything that is a game item really should have this method called use, but I don't have any clear default behavior for that method. I don't know what should be used, what should happen when any item ever is used. There's no default behavior here. So I'm just going to leave it up to the concrete classes to implement that behavior. I'm just going to know that that method does exist. Yeah? Kind of. So would the body of the abstract method always be empty? The body doesn't even exist. So there is no body. If I have open brace, closed brace right here and just an empty body, I'll get a syntax error and Java will be like, hey, you can't have a body in an abstract method. We just cap it off with a semicolon and we can't have a body to it at all. Is it calling, so player, I'm defining the parameter list. So I'm saying anything that extends game item will have a method called use that takes a player as a parameter and returns void. But we're not defining what that method should do at all. We're not saying that method will do this or that or anything. We're just saying it will exist and then leaving it at that. It will exist. What this gives us is if we have an object in a variable of type game item, we know that method will exist. So we can call it from our variables of type game item without having to give it a default behavior. So what we did before, we had some use cases where we could have used abstract methods when we were talking about inheritance. So when we had this exact method before, and instead of talking about abstract, we would get rid of the abstract and we would say equals open brace, closed brace. And we did give it a full definition. It wasn't abstract and it had default behavior of, actually this one didn't. For sometimes we had default behavior of doing nothing. For the use method, we actually had default behavior that printed to the screen, item has been used or whatever we did. We did something silly to avoid abstract methods. But that didn't actually make sense. It didn't make sense to have default behavior in the use method because a weapon is going to have some behavior when you use it. A potion is going to have some behavior that's going to have when you use it. And those two behaviors are going to be very different from each other. There's no common ground that can be in the game item class and say every game item when it's used should do this. So it makes more sense for this method to be abstract and say my extending classes are going to take care of it. But since the method exists, we know of its existence, we can call it through variables of type game item. We can take this one step further and create something called interfaces. So interfaces in Java are kind of like classes. They have the same syntax as classes, except they can only have abstract methods. That's the only thing they're allowed to have. Abstract methods only. When we want to use inheritance with interfaces, we use the implements keyword instead of extends. And our interfaces, and then we have the obligation to implement every abstract method from the interface. Interfaces can only have abstract methods, so all of our usual things from classes, no instance variables, no constructors, no methods with definitions, can't have anything in these interfaces except abstract methods. So we have an abstract method, and since it has to be abstract, we can actually leave off some keywords. We don't need the abstract keyword. It's an interface. It's implied that it's abstract. Java or IntelliJ, I think, will be like, why even putting that? Why even putting the abstract keyword here? It has to be abstract. I know it's abstract. You know it's abstract. Let's just not talk about it. We don't have to put it there. I'm also leaving off my access modifier. We usually have public, private, protected. We haven't talked about protected, but we usually have an access modifier here as well. When you're And let's just say we did have an access modifier and we made it private. We made this variable private. Private means you can only access that variable, this method private. That means you can only access that method from within the class itself, in this case an interface. But an interface can only have abstract methods, so there's no way to actually get code into this interface. So having a private method just doesn't make sense. Why would you have a private method in an interface that you can't call? It would just be code that you can't use at all. So Java takes this a step further and says every method in an interface, all these abstract methods, must be public to the point where we don't even have to say public. So this is a public abstract method, but we don't have to put public or abstract. It's just implied because it's an interface. So the reason to use an interface is, again, polymorphism. That's going to let us say these methods will exist. If somebody implements this interface, these methods will exist in anything that implements that interface, which in this example really makes sense for our comparator. Comparator always should have been an interface, but we just weren't talking about interfaces yet. When we created our comparator, we created it as a class, and we gave the compare method the default behavior of something. It returned 0, I think, on every single, no matter what the inputs were, every single call. And then we always overrode that compare method. But it doesn't make sense to have any default behavior here of how we're going to compare two objects of any type. There's no concrete, this is what should happen whenever you call compare, no matter what. So we make it abstract and just leave it up to the implementing classes to implement the compare method by however they're going to implement them. So our int decreasing can implement the comparator interface and then do whatever it wants with the compare method, implement it any way it wants. And as you know by now, I'm a big fan of the override annotation. This is one case when we have abstract methods like this that we're overriding where the annotation doesn't really help us that much. I'll still do it just because, it's a habit at this point. But there's not a big reason to have the override keyword here. You still get some benefits. It does make your code more clear that you are overriding something that was from an interface in this case. But if you don't have this keyword, so one of my big pitches for the keyword is for the annotation is that if you make one typo, if I have a capital C here, for example, the annotation is going to say, oh, hey, you're not overriding anything. What are you doing here? And then you can go and find your typo and then fix it. In this case, when we're overriding an abstract method, if we leave off the override keyword and we have a typo, we're still going to get an error because we have a contract. We signed a contract. Once we said implements comparator of integer, we have a contract to implement this compare method that takes two integers and returns a Boolean. We have to implement it. So if I have a capital C there, Java's going to say, hey, you didn't implement that method. You promised me you'd implement that, and you didn't. What the hell? And then you can go and find your typo and fix it. So you don't have the same issues. So if this isn't here, it's not as big of a deal when you're overriding an abstract method. Okay, why interfaces? Why not just abstract classes for everything? You can implement multiple interfaces is the big advantage with interfaces. So interfaces can only have abstract methods, which avoids a problem that we can have when we're extending classes or abstract classes. So say we can only extend one class or abstract class. We can only extend one thing. So say we were allowed to extend multiple classes, and we extend two classes. Both of those classes have the same method, the same name, same parameter list, same return type, and they're not abstract methods. In both classes, there is a definition for that method. We extend both of them. We get two definitions for the same method, create an object of that type, and then call the method. Which definition should be used? We have two definitions for the same method, and everything gets confusing, everything blows up a little bit, and we don't know what to do. Java's answer to this problem is to say, well, we're just not going to let you do that. It says you can't extend two classes or abstract classes, only allowed to extend one thing. Only one thing. But you can implement as many interfaces as you'd like because they're all abstract methods. They can only have abstract methods, so there's no harm in implementing 100 interfaces if you want. You can implement a whole bunch of interfaces. All an interface says is anything implementing me must have these methods. And the advantage, of course, is that we can code to the interface. I can have my BST take a comparator and know that it has a compare method. We don't know anything else about whatever we're given. We just know it has a compare method because that's what the interface guarantees us. The interface guarantees, hey, anything that implements me has to implement the compare method. In Java, the compiler, it's all going to enforce that. And this, I kind of said the phrase, but this lets us do something called code to the interface, which is generally good practice. If you're writing code, it's generally good to go as high up the inheritance, the type hierarchy as you can. This is more of a sidetrack, by the way, but this won't be on an interview. But it's generally good to code to the interfaces. So if you have something that implements an interface, and you can get away with just using the interface methods, it's good to write code that codes to that interface. So this briefly came up when we were talking about reading files, and I said the read all lines method returns a list, but that's has something to do with interfaces that we haven't talked about yet, so we're just going to say new array list and wrap that list in an array list, which generally isn't what we really want to do. What we would like to do is code to the list interface. So list is an interface, meaning list defines a handful of methods that anything that implements it must define. And then array list is going to implement that interface and also add some other functionality onto it and be a concrete implementation of a data structure. But the list interface itself says, okay, if you implement me, you're going to have a size method, an isEmpty method, contains, an iterator, so we can write our loops, our for each loops use the iterator. So anytime you have a loop, you're using this. ToArray, another ToArray, an add method, an add all method, a remove method, contains all, add all is somewhere down here, add all. So all of these methods must be implemented in anything that extends list. So if you can get away with just those methods and you're writing a method that takes a data structure, if you can get away with just using these methods, it's generally better practice to code it to the list interface. Write a method that takes a list instead of taking an array list. Like we've used array list or linked list for everything so far. And further, if we go all the way to collection, list extend, the usage of keywords here is confusing. I don't know why Java does this. If you have an interface that's inheriting from another interface, you use extends instead of implements. I don't know why. But collection is another interface, which extends another interface. Collection restricts things a bit more. Size is empty, contains, iterator. ToArray actually has most of the same stuff. ToArray again, add, remove, contains all, add all. Actually, I don't even know what the difference is between these two. And then that extends iterable, which is a bit different. This is just anything that can be iterated over. So it has our iterator method and not much else. Oh, I was trying to avoid this default keyword. But you can iterate over it, and that's it. So if you just have something you need to loop over, you could even code all the way to iterable. So the reason for this is if you have a method that takes a list, so if you have a method that takes an array list, anybody using that method has to use an array list. They have no choice. You didn't leave them any options. But if you code it to the list interface and somebody wants to use a linked list, Java's built-in linked list, well, linked list also implements the list interface. So if you have a method that takes a list and somebody wants to use a linked list or an array list, they're welcome to do that. They can use whatever data structure they want to use. Or if you go all the way up to collection, all the way to, collection. If you go all the way to collection, anything that implements the collection interface, either directly or indirectly through the list interface or any other interface, you're giving anybody using your code the freedom to use a lot of different data structures, or they can implement their own data structure. We don't want to say they can't do that. If they implement the collection interface and implement their very own data structure, and they want to use your method still, they can still do that. You write a sorting method, which we can go there, right? Use collections.sort. Oh, hoping we wouldn't get crazy syntax like this. Ignore that part, but the sort method in Java takes a list. It can sort linked lists, it can sort array lists, it can sort any data structure that implements the list interface. So this gives us the most flexibility that we can get. Instead of saying you must use an array list if you want to call my method, we're saying, hey, as long as you got something that implements this list interface, you're good. I'll be happy with it, and I'll happily sort it. So we want flexibility, and that's a lot of what our OP conversations are about, making our code flexible, easy to maintain, easy to extend, and that big CSE 116 question of what happens when our programs get bigger. We want to keep things organized and flexible so we can quickly update our code, add new features, maintain our code. If we have a bug, we want to be able to identify it quickly. That's hard to do if your code's a complete mess. So we want to keep things organized and flexible. That's our goal. All right, so any questions on abstract classes, abstract methods, interfaces? How would you show in the method signature that you're implementing multiple interfaces? Oh, yeah, I didn't talk about that. So that was just on the screen. I closed them all, of course. But it's a comma-separated list. So the array list class extends one abstract class, but it implements a comma-separated list of interfaces. So it implements all of these interfaces. You just comma-separate them. What would the syntax for multiple implementations be? I got that. Public class example implements A, implements B, implements C. Oh, yeah. Follow up to that. I notice that your implements within a method rather than at the top of the class header. What's the difference? I notice you use implements. This is in the. I might not understand this question, so let me know if I'm missing something. So this is in Java. If you're talking about when I showed this code, this is inside Java itself, and this is the definition. This is the definition of the class, just like we've done it, not in a method. I'm not sure what you mean by seeing that in a method, implements inside a method. It's on line 109, but that's because there's a lot of documentation up here. But the next thing is the imports. We got a lot of extra stuff here, but it's the imports, the package declaration, the imports, and then the start of the class. It's just line 109 because there's a lot of documentation. We're not in a method at that point. But we won't use implements within a method. The way we use implements, the way we're about to use it on... I don't have it open. The way we're about to use it, that we'll see in the next slide deck, is Potion extends game item and implements usable. Oh, damn it. I didn't scroll up. Okay, any other questions on abstract and interfaces? Yep.
Will Java packages tell you if they're abstract?
And when you import the packages, not quite.
Array list that was
Yeah, it extends the abstract class. Yeah, so if we go to the abstract class, this is going to be or an abstract list. This will be an abstract class that there's a whole hierarchy of all the data structures in Java. There's a lot of inheritance going on to implement these. Maybe related to your question, but in IntelliJ, in the side here, it'll tell you, like, these are classes. This is an abstract class, and this is an interface. So the symbols there will give you some information about them, but not necessarily when you import them. When we import, we'll just, like if we imported, yeah, in your naming convention, as you can see, like abstract list is an abstract class. Yeah, you just have to kind of know. Naming conventions can certainly help. Some people used to, I forgot about this actually until just now. I think people used to use this as a naming convention. Like if it's an interface, you started with capital I. If it's an abstract class, you started with capital A, I believe. I don't know. I always hated that, personally. But through the names, yeah. Okay. Get on with it. So in polymorphism, our big thing that is polymorphism, if an object is a type, it can be stored in a variable of that type. This includes classes it extends, abstract classes it extends, or implementations that it interfaces that it implements. There's so much vocab in OOP. I have trouble getting it all straight during a lecture. So with that in mind, let's go through this code. This will be our memory diagram for the day. So this code doesn't all fit on my slide with the memory diagram. So this is the first time I'm going to swap out code during the memory diagram. So let's look at the whole program for a bit while we have a chance. So we're going to create a player, weapon, and potion. Weapon and potion are now going to extend game item and implement usable. So we have kind of this multiple inheritance going on. Game item doesn't actually have any abstract methods. Part of the reason for that is just because I did everything I could to trim down this code to fit it on the slide, and I still couldn't get all the code, like not even close. I have about 50% more code than I can fit without putting the font way too small. So it has multiple extension. Game item doesn't have any abstract methods, but I'm still making it an abstract class, and this is actually fairly common. Personally, I do this all the time as well. To have a method, a class that could be a concrete class. We don't have to have the word abstract here. We can have game item be a full concrete class without having it be abstract. That'd be perfectly legal code. But for my application, I really don't want anybody instantiating game item. When I have this game, I don't want an object of type game item anywhere at all. I just don't want that to exist. So I'm going to make this abstract just to prevent people from creating new objects of type game item. If you want to create an object, a game item, you're going to have to create a weapon, a potion, a Molotov cocktail, a chainsaw, something that makes sense in the game. Just having a generic game item doesn't make sense at all. So make it abstract. Don't let anybody instantiate it. If anybody tries, the compiler is going to get your back and say, hey, don't do that. Jesse said, don't create a game item object. And that's going to prevent it. And then our big polymorphism stuff, our player is going to have an array list of usable as their inventory. So anything that implements the usable interface, of course, can be used by the player. And the player can pick them up. We have a method that takes a usable as a parameter. So we have our two big payoffs for polymorphism right here. A method that takes an interface now as a parameter, or an abstract class, or really any supertype. And a data structure that has a type that is a supertype. These are our two big payoffs for polymorphism. Once we have a variable of type usable, the only thing we can ever do with that object is call its use method. Well, that's fine. We're going to not call anything on it here. We're just going to add it to our inventory. Then when use all items is called, we're going to iterate over all our usables. As we know now, abstract list implements the iterable interface, so we're allowed to loop over it. That's why we're allowed to loop over it. And that's where we're going to call the use method. on this, which is a reference to the player that called use all items. In the full code, there's more code in the repo. Again, I trimmed a lot of this down. For example, clearing out the inventory after all the items are used. I removed that code. Yep.
I was trying
Mm-hmm.
the class readable makes sense to be abstract since we don't want to make everything.
Yeah. Yes. Oh, I thought you were going. I thought you were saying more with that. Yes, absolutely, Bill. Relating this to the homework, the rateable class, it would make sense for that to be an abstract class. Yes, absolutely. That really should be an abstract class because we don't want somebody saying new rateable. I want somebody saying new song, new movie because those are actual tangible things. A rateable isn't a tangible thing. It doesn't make sense for to have a rateable. I can't say, hey, did you see that rateable last week? That doesn't make sense. Did you hear that new rateable? No. Did you hear that new song? Did you see that new movie? Makes sense. So it should be abstract, but I just didn't add it to the programming requirements to make it abstract. Mostly because I'm not set up with my grader yet to make sure it's abstract. So you would get away without having it abstract, even if I said you had to. So that's really the reason why it's not abstract. No, that wouldn't make sense. I was going to say it could even make sense for it to be an interface. It can't be an interface because we have a lot of functionality in the rateable class, all the ratings, managing ratings, all that stuff. But it definitely could be abstract, should be abstract. And if you make it abstract in your code, by the way, it'll be fine in AutoLab because it should be abstract. Okay, let's memory diagram this thing. So for these first few lines especially, we're going to do quite a bit of chunks of memory diagram stuff in one click because we've seen it before. So I'll review still, but I'll go quickly through the parts that we've seen 100 times and then slow down when we get to the polymorphism stuff. So player, create a new player object. Player doesn't extend anything, so we're not worried about inheritance here. In the repo, it does extend game item, but again, I remove stuff. It gives me one less stack frame. It doesn't really save me anything here. But when we create our new player, call the constructor. There's no explicit constructor here. When there's no constructor in your class, you get the default constructor that takes no parameters and doesn't do anything. That still goes on the stack. When you're saying new something, that thing still goes on the stack. And anything that extends, those constructors still go on the stack, even if there's no explicit constructors there or explicit superconstructor calls. All that stuff goes on the stack. So here, player goes on the stack, and then technically the object constructor goes on the stack. But as always, that's internal to Java, so we're not worried about it in our memory diagrams. But we do get our default constructor, and then we're initializing our variables as soon as we're declaring them instead of initializing them inside the constructor. So we do get our initial values for all of these instance variables, including inventory, which is a new array list, and we use our T-chart where these are the indices and these are the values at those indices, then the reference 200 for our array list. Okay. So let's put the player class aside for now and talk about the rest of our code here. We're going to construct our weapon and potion. Remember, with inheritance, whenever you extend something, the superclass constructor must be called. So weapon extends game item. So when we create our new weapon, we create the variable. We put a stack frame for the weapon constructor. The weapon constructor calls explicitly in this case the superclass constructor, which is game item in this case. The game item constructor is called, and we get our values initialized. The game item constructor initializes location. The weapon constructor then continues and then initializes damage, and then returns a reference to the object that was created to the main stack frame. And in each constructor call, we have a reference in this, which is a reference to the object that's being created. So we have two constructor calls to construct one object, as we've seen before. Same with potion. Potion is going to call its superclass constructor. We get two frames on the stack, two constructor calls to create one object on the heap. When we implement interfaces, it doesn't change our memory diagram at all. So you might be tempted to say, well, weapon implements usable, so I'm going to have a usable constructor on the stack here. No, not at all. It actually doesn't affect our memory diagram in any way. So usable is an interface. Interfaces can only have abstract methods, which means it can't have a constructor. It's not a case where we don't have a constructor explicitly defined, so we automatically get the default constructor. Interfaces don't have constructors at all. So it can't be called because it doesn't exist. An interface is just saying anything that implements me will have this method. Or methods. It can have multiple methods, of course. No constructor call. It doesn't help in creating objects or anything. All it's saying is, hey, when I implement usable, that means I'm going to have a use method that takes a player and returns void. It's the only thing the interface does for us. So interfaces do not change our memory diagrams at all. We're still only going to the superconstructor that's extended, nothing that's implemented. So it's kind of a new change that we're using interfaces, but the change is we're doing things the same old way. The weapon object, I'm storing that reference in a variable of type weapon, which means that I have access to everything defined in the weapon class, everything known to the weapon class, including anything from game item, anything from usable. I have full power since this is stored in a weapon object. But when we get to potion, I'm storing that in a variable of type usable, which means this potion variable, since it's of type usable, I can only access the use method. It's the only thing I can do with it. Usable only knows, the only thing it knows is the use method. So that's all we can do with this thing. Call use on it. The only useful thing we can do with it is call use. And I could do this, I'm doing this just to show the point, but these could both be usable. This could be weapon and potion. This could be usable and potion. I'm just showing that, hey, we can embrace polymorphism here. What we kind of can do is store either one of these in a variable of type game item. That would be a legal assignment. Say I had this variable type game item, but on the next line we'd run into trouble. Pickup takes, I'm looking for it, it's not on the screen right now. Pickup takes a usable as its parameter, and the game item class doesn't know about the usable interface. Game item does not implement usable. You might argue that it could, and then we could do that. But game item doesn't implement usable. So if this were variable type usable, we would not be able to call a method, if this was a variable type game item, we wouldn't be able to call the pickup method, which takes a usable, because game item doesn't know about anything that is usable. Usable isn't part of the type hierarchy of the game item abstract class. So we wouldn't be able to do that. So the assignment would be legal if this were a game item. But once we got to this pickup method call, that would not be legal and that would not compile. So the types of the variables to determine which methods can be called. And then when we call pickup, we're going to add those items to our array list. So we get our array list of type usable, which has a weapon and a potion in it. We have mixed types in our data structure. Finally, yay. And then what happens when the actual methods are being called? So we're actually going to call the method. The variable type determines which methods can be called. So we're iterating over an array list of type usable. So our items are going to be of type usable as we're iterating over them. So that means we're allowed to call the use method, and only the use method. We can't do anything else here. But what happens when the use method is actually called? This is the other half of the point. So variable type determines what we can do, but what actually is done is going to depend on the type of the object. Always, always, always depends on the type of the object on the heap. So when I call item dot use, I'm calling that method from an object of type weapon. And this is exactly the same as we've done it all semester. We got to a variable of type weapon. So we go to the weapon class, look for our use method that takes a player, we find it, and we call it. That's the method that's called. Depends on the type of the object. The next iteration of the loop, we're on the potion. We call use, item.use, item.use. We called it from an object of type potion. So we go to the class matching the type of the object, not the type of the variable. We're not looking at the usable interface at all. Usable just determines whether or not this line of code compiles. It does not have any bearing on what that method call does. So when we call this on a potion, we go to the potion class, look for its use method, we find it, and this is the method that's called from the potion class. When we call use from an object of type potion. So we have a data structure inventory that stores usables. It has two usables of two different types, weapon and potion. And then we iterated over the values in our inventory and called this line of code twice. We called this same exact code. We have item, which is of type usable. We called .use. We passed it a reference to the player. The player, this is 350 in this case. We passed it the player. But we got two very different behaviors each time we called item.use. Even though the code looks exactly the same, the first time we called this method because we called it through an object of type weapon. The second time we called it, we got this method because we called it through an object of type potion. Depends on the type of the object on the heap, not the type of the variable on the stack, I guess, but it could be an instance variable, not the type of the variable. Which is the same way it's always been. So the big highlight, again, is no change. Maintain status quo. It just gets trickier because before you could, if you didn't understand that, you would just look at the type of the variable and you'd get to the right spot no matter what. But now you look at the type of the variable and it's usable. You say, okay, usable.use, and you go to the usable interface, you find the use method, and you say, oh crap, there's no definition here, and I got an abstract method, what do I do? And then you panic and everything breaks down, and then the TAs are like, hey, time's up, hand in your quizzes, and you're like, ah, shit. So you go to the heap, you use your memory diagram, you go to the heap, and you find the type of the object, not the type of the variable. And again, for your quizzes, the type of the variable doesn't even factor into anything you're doing because the code we give you is going to compile. The type of the variable only determines if the code will compile or not. Is it valid code or not? That's the only thing the type of the variable does. So everything on your quiz, you're worried about the types on the heap. And then the program ends. Any questions on polymorphism? Yeah.
I'm struggling a little bit to see the difference between abstract.
Mm-hmm. Yeah, so and we do have time to do some live coding, so let me do it through live coding. Get rid of my garbage down here. We didn't get to any live coding in lecture 1, but... So game item, I'm going to make this an abstract class. And we do have, all the code that we want in here at this point. But I'm going to make this an abstract class and make the use method abstract. Public abstract void use player, like we had before, except we have all of our other code as well that I removed for the slide. So that's an abstract class. It's any class that has at least one abstract method has to be abstract. If I have that abstract method and I try to not make this abstract, Java's going to yell at me and say, hey, make this abstract. Either make this abstract or finish your method. But other than that, it's a full class. It has all of the class stuff, everything that we can do with any classes. It just happens to have at least one abstract method or no abstract methods. When this, if this, like we saw in the slides, if I don't have any abstract methods, I can still just make it. I can go make anything abstract. If I want to make this abstract and say nobody can create a health potion, I just make it abstract. Now you can't call the constructor. Between that and an interface can only have abstract methods. No constructor, no instance variables. If I try to make an instance variable here, not going to let me. X might not have been initialized. Equals 0. Oh, Java, come on. Don't do this to me. Can you really have variables in interfaces? Oh man, what'd I break here? Because I got rid of the... Maybe you can have variables in interfaces. That doesn't make sense at all to me. Well, I'll have to look into that one apparently. But I can't have a definition of this method. I'm not allowed to do that. Well, I was going to say for sure, but I don't know anything anymore. Oh, that's not the right syntax. But I can't do this. Interface abstract methods cannot have body. Can't do it. And I can't have a constructor. Not allowed. Not allowed. See, that's what I